For example 4, we can extend this concept to 3 terms. So you could have 3 monomials, you could have 5 monomials. You can extend this to as many terms as you want. The only thing that you have to do is make sure that you look at all 3 terms once you break them down. So for example number 4, I'm going to break my 22 down into 2 and 11. So the prime factorization would be 2 times 11 xxy. For the second term, and you'll get better at this with time, I divide by 2, takes me to 22. And then I'm a fan of not reinventing the wheel. Didn't I already break 22 down? It was 2 times 11. So I really don't have to think too much on that. 2 times 11, x, y, y. And then of course we go to this third term. If I divide by 2, it takes me to 33. And then I divide by 3, takes me to 11. So I could write this as 2 times 3 times 11, x, 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 y. And then as I look at these 3 prime factorizations, I want to see what all 3 of them have in common. So it's obvious they all 3 have a 2 to offer. They all have an 11 to offer. They all have 1x. See, I can only underline 1x here. The same with this one. And then when I go to the y's, they all have just one y that I can underline. And so then I would list out my GCF. Now the GCF would be, I'm only looking at one term when I do this. 2 times 11 is 22 xy. Let's go to an example 5. With example 5, maybe I'll have something like 20 AB, and then 9 Y. I'm going to break these things down. As I break them down, this would be 2 times 10, and 2 times 5. So this is 2, 2, 5, AB. And then with the 9, it would be 3 and 3, so it's 3 times 3, Y. This brings up an interesting idea here. As I look at this, I see nothing that can be underlined, and I hope you learned from a previous example, I believe it was example 3, when they have nothing in common, your GCF can still be listed out. The smallest GCF you could ever list would be 1, because I wasn't able to underline anything here. Now, there is a special word for this. We call these things relatively prime, meaning that they don't have anything in common. If you have 2 terms that have nothing more than a GCF of 1, they're called relatively prime. Relatively prime. And I think we should just throw one more example on here to make sure you understand your ultimate goal when trying to find GCFs. So we'll call this example 6, and we'll do something like 24 x squared y, and then maybe we'll do 30 xy squared, and then, well, what the heck, we might as well do 3 terms here. Let's do 66 x, and then see what we can do with that. As you look at the first term, you can break this down by dividing by 2. 2 times what gives you 24? 12. And 12 can be broken down as 2 and 6. And 6 can be broken down as 2 and 3. So I have nothing but prime numbers on the outside here. This would be 2 times 2 times 2 times 3. xy. And then you want to break your 30 down. 30 would be 2 and 15, and 3 and 5. So we can call this 2 times 3 times 5, x, y, y. And finally we get to our 66. We can divide by 2, which would take us to 33. Divide by 3 takes us to 11. So we call it 2 times 3 times 11, x. Now as you look at all 3 of those prime factorizations, you want to underline what all 3 of them can offer you. And so you would divide, or underline, I don't know why I keep saying divide, put a 2 here, a 2 here, a 2 here. They all had a 2 to offer. They all have a 3 to offer. And then in terms of the variables, the only thing that I could take from each of these would be an x. So they all have an x to offer. And then your G, C, F would be, and you only look at one term when you do this. I only look at one. It doesn't matter which one, but you can only look at one of them. So if I look at this, it would be 2 times 3 is 6. And then they had the variable of x to offer. So the GCF is 6x.